So the book also talks about different ways of transmitting power to your rotors. On the left here, I have a transmission where it's connected directly to the engine through some gears and a gearbox. And then we have our main transmission, which drives the main rotor and also the tail rotor. Now, there are some upsides and downsides to being direct connected to your engine via a gearbox. You can have issues where some vibrations get transmitted through the gearbox. And of course, gears can start producing metal. I mean, that's true in the transmission itself, but it's also possibly true here. So on the right, we have something which is very similar to what you have with the Schweitzer, for example. And you have your lower pulley assembly, which is connected to the engine. And then you have your upper pulley assembly. That's where that sprag clutch or freewheeling unit is located. And then you have something called an idler pulley. And essentially what you do is you pull this idler pulley and it produces tension on these belts. In the case of the Schweitzer, there are 8 of them, and it tightens them so that it transmits the power between the engine and the rotor system. And it's a very simple system. There are some helicopters out there, by the way, that instead of having a manual clutch system, they will have a centrifugal clutch. I can think of the Rotorways, the home-built helicopters, are one such system. So there is no clutch switch, as you would find in the Schweitzer and also in the Robinsons. So here we have the clutch switch in the Schweitzer. You'll notice that it's currently up and it has the guard installed. That's to keep you from accidentally disengaging the clutch. Now, this is a 300 CBI, which has an auto-engaging clutch system. And what does that mean? Normally, if you don't have an auto-engaging clutch, you have to manually pulse this thing in so it doesn't stall out your engine if you just kind of dump the whole thing all at once in, between the engine and the rotors, which are not really spinning up to speed yet. So I can disengage my clutch and the little warning light will come on. Now, if I look at my tack, you'll notice that down here, I have split those needles. Now, if I wanted to engage it and use the auto engage system, I basically push it up to engage. And I normally hold it there for 3 seconds. In the actual helicopter here, I just flipped it up. And you notice the green auto engage light came on. And if I go back to my tack, you'll notice, see how the engine dropped a little bit? And the RPMs are coming up. And what's going to happen is you'll see the red light flash on and off. And once we get these needles to being superimposed and the red light has gone out for usually I say 5 seconds, then I put the switch all the way up, put the guard on. So this is coming up to speed. So I can go back to my clutch switch. I see that the red light has gone out. I push this all the way up and I put my guard back up. And now I can go to my ground idle of 2000. So what about the Robinson? The Robinson also has electric clutch. So here in the R44, it's currently engaged. There's a guard on top of it. Let's see if I can successfully move it to the off position. So I've moved my clutch to the off position, and to turn it back on, I can just simply go forward with the guard. Now if I look back here, I just run things up, and now life is good. And my rotor's spinning. Now the Robinson rotor's going to spin up faster because it's the low inertia, or as I like to say, no inertia rotor system. So when I'm done with my flight, I can roll down my speed, and then I can go back and disengage the clutch. That's the Robinson.